Hello, my name is Michael Spencer with Reynolds Farm Equipment. I'm our CDI, or Certified Dealer Instructor within the organization. We wanted to spend a little bit of time going into the heart of spraying here in 2025 to discuss some key topics on your guys' self-propelled sprayers. Mainly tips, tip sizing, tip selection, and the general wear items or maintenance items that we need to understand about the sprayers before we go to the field. So I was going to try to define the different styles of tips, and then we'll speak to the technology itself. So really, when we look at the John Deere offerings that we really have tips that are designed for herbicides. We have tips that are designed for high flow and fertilizer applications. And then we also have tips specifically designed for fungicide and plant health. So that's the first thing we need to decide on what we're doing. What pass are we making? What product are we putting down? And then that will dictate which one of these options we want to put on the sprayer first. Then we decide what size we need. So what historically guys have always ran is just the ultra low drift or the low drift max tip. This has been an extremely reliable solution for us and gives us a large range of speed options as well as droplet sizes. So it's been fantastic for a long time, and a lot of sprayers are still utilizing this tip. What I want to make sure we understand, though, is there's newer technologies and newer options that we really need to consider, and I'll define the why here in a minute. So first off, we'll go with more of a herbicide application because that's the type of season we're in right now. So I'm going to go ahead and turn on our mock sprayer here. This represents our 15-inch on center nozzle, so just ignore this for right now. But what we have spraying is the low drift max option that has been extremely common in our area. We have a great fan design and good overlap. The problem is if we change our pressures much or our speed, we don't have as good a control of the droplet size as what we could have. That is where I would like to highlight the ultra low drift max. So allow me to turn these on here and kick those back on. Right away you can see that we have a lot better coverage where we're overlapping almost 100%, but we're also spraying with what looks like a really large droplet. The reality of it is this is an air-injected technology that not only works great on a conventional boom, but if you do have an ExactApply nozzle body, these are 100% approved for those as well. One of the few nozzles that are approved for ExactApply that does have a level of air induction. So I'll turn this back on. Now we're looking at the ultra low drift max solution. So this is a newer style tip that has a wider fan pattern, as we can see here. So we have 100% overlap with this tip. And from this video, you can probably see how much larger those droplet sizes are. Well, this is actually an air-inducted nozzle option that is a great solution for our conventional booms, but it's also one of the very few air-inducted nozzles that are approved for the ExactApply technology and the pulsating within those nozzle bodies. So, and the reality of it is, although we're an ultra-coarse droplet, it actually lands as a fine or ultra-fine droplet on the plant with how that droplet will explode and land on that leaf material. So this is a fantastic option for herbicide, and really we have customers that are utilizing this for fungicides as well. Now I'd like to highlight a couple of the plant health or fungicide application options that we have as well. These are two really good twin pattern options that Deere has today. This has been one, the Twin Air, has been on the market for quite a while and is an excellent option for a conventional boom. The issue is this air-inducted tip is not approved for ExactApply, so do be careful there. Where here lately, Deere has released a twin pattern that is approved for ExactApply. So this is a fantastic option for either the conventional or an ExactApply sprayer boom. Now with those tips on, just to give you a good representation here, we are a twin pattern, so we're spraying both the front side and the backward side of that plant as we move through that field. So this technology is fantastic for fungicide, just to make sure that we're coating that whole leaf material. The only difference is with the Twin Air being an air inducted, we can control our droplet size just a little bit better than what we can with this newer style. So this, you could bridge that gap between a herbicide pass and a fungicide pass. I don't know that I would recommend that with this, just by how many fines that you can see, or the dust or the fog coming off of that tip. But frankly, that's a great option for in-field solutions for fungicide. Lastly, and maybe a little less known solution, is this stream nozzle body that is fantastic for fertilizer or top dressing wheat or those type of applications. I have seen some guys on the Exact Apply nozzle body shut every other one of these off and side dress, if you will, nitrogen with their ground rig in corn, let's say. So if we take a look at this, it's just a high flow option that's going to stream 28 into the row or onto the ground. Specifically, this was designed to be able to get through the canopy on almost mature to early stages of wheat. So it does a great job getting that fertilizer to the ground without burning the plant. And one thing that's special about the John Deere tip is we have 6 streams versus just 3 or 4 on some other competitor options. So it really helps us maintain flow and get a good even distribution on the ground. The next important step within nozzle selection is probably the hardest step: understanding what tip size that we need. Again, first let's identify what tip technology. Are we spraying herbicide, fungicide? What type of nozzle body or nozzle boom do we have at PWM and Exact Apply, or a conventional sprayer? Once we have that out of the way, then we have to pick the orifice size. And I don't care which technology of tip you're using, what we're getting ready to define is exactly the same. So the way Deere tips work is they're all color coded. So a blue is going to be an 03, a red is an 04, brown is an 05, gray is an 06. Those are our most common. There are more sizes than that, absolutely, but that's the color combination. And what that color tells you, again, is that orifice size. But what orifice size do we need? I have always used just the math, but Deere has a mobile app, Equipment Mobile, that will have a tip selection tool in it. There's charts that T-Jet, Hi-Pro, all of those charts will reference the same material. And if you understand this math and understand those charts, you'll be able to understand which orifice size you need. So looking at this example, we're going to be spraying at 15 miles per hour with a total application rate of 12.5 gallons per acre. And we have 15-inch nozzle spacing. The only difference would be 20. So if you have a 20-inch nozzle spacing, we need to make sure that we define that there as well. And we're going to divide that by this constant, 5,940. Once we do this math, we get this 0.47348. That tells us what orifice size we need in that technology. So in this case, a 4.7, I would, at that point, round up to a brown tip or an 05 tip, and this will get us the correct size. So looking at the tips, we got to decide what orifice size we need, or what size of tip we need. Now the reality of it is, once we just define what technology we need, that ultra low drift max, the low drift max, the twin air, whatever technology that you're wanting to use, the color codes or the orifice size is exactly the same. So hopefully by defining the math, we'll be able to more easily identify what tip size we need. So if we look at the bags of any of our tips that we sell across the counter, it will highlight that they would like us to try to keep or have that median range at 40 psi. So let's keep that in the back of our mind, that we want to try to use these numbers at 40 psi. And once we understand that, we need to know how fast we plan on driving. So in this case, we're going to go 15 miles an hour. What's the total application rate? So in this case, 12.5 gallons per acre. and then the nozzle spacing. So for our boom today, we're going to have a 15-inch nozzle spacing. If you have a 20-inch nozzle spacing, you would just want to make sure that you adjust your math there. And then we're going to divide that by the constant, 5,940. So that's going to give us a 0.47348. Now what we do with that number is we'll take a look at the graph, and we're going to follow down that graph and decide where we fall. Now, are we going to find an exact 4.7? Probably not. It's probably going to be somewhere closer to 4.5 to 5 point something. We always want to make sure we round up in that case. So if I look at this number, I'm just going to go ahead and do that math. I'm going to round this number up to a 0.5. So that tells me I need a brown tip in whatever technology I want. So now let's take a little bit of time to make sure the nozzle body and the nozzles are ready to go spray. So in this case, we're going to take a look at our conventional boom, or with our 5-way high flow nozzle tips or bodies. So when we take a look at that, on the side of the nozzle body itself, there is a check valve. You'll want to take this apart and make sure that that diaphragm is free, clear, and can spray. Honestly, the best way to do that is just to turn the sprayer on, run at a lower PSI, and let's just make sure that all those tips are spraying. So as we can see, this guy here is turned just wrong enough that we need to get that out of there, and you can see it working to get that pressure built back up and past that diaphragm. We may need to take that apart and take a look at it and see what's going on there. The next thing that we need to define is to make sure that the tip itself is clean and free. So if we take this off, we should have an O-ring and a filter. Yes, there's a filter in there. And those should sit in clean and freely. And then look and see if we can see through those jets or those orifices, and that the nozzle tip itself is clean and free. We do sell a cleaning kit. It's called SpotOn. That will allow you to push 50 pounds of air, forced air through this. It's just a plunger. So you put this at the end of the tip and you can push air through it to lodge any debris that may be in there. And it comes with brushes and a toothbrush to really be able to maintenance these well. These should last you quite a while as long as we take good care of them or run a good neutralizer, like a product like Erase, through these tips. But this is a much easier time to make sure that they're going to function correctly. Then when we reassemble, we simply want to make sure that we go back together with it and clip it back onto the turret itself. And it should not move or wiggle at all. So if I would take that O-ring seal out of there and I would try to put that tip back on here, you will see how it's not on there as tight as it will. That will leak if you try to utilize that. Trust me, easy to drop these. Once we see that the flow through the tips and the nozzles are good, we want to make sure that we're getting the value or that flow rating that we can expect. This is frankly one of the most important tools that you can have on the sprayer. This is a flow gauge or calibrator for the tip. This will not only tell us that we're getting the right amount of flow through this tip, but it will also reassure us that the sprayer is pushing enough product through the boom to achieve that rate. So simply turn this SpotOn on, we'll put it in, and let this tube fill all the way up. And it will have a self-timer on it, which makes these really nice. You don't need to keep a stopwatch or anything. Once it gets to that point, you can take it off. You can see where those points are with those electrical diodes. And what's really helpful is if you understand the charts or the readings, if I have a brown tip, I should expect this to be 0.05. So now what I've done is I put a tip that I may or may not have took a file to. This should be a really good representation of what a worn nozzle tip would look like. Now, yes, dramatic, I know, but hopefully this plays well. Where we can see a well-defined pattern in our spray here, where here that pattern's terrible. We're not getting very even fan. Our droplet sizes are different across the pattern itself. Not going to function very well. The other thing is, if I put this calibration tool on here and I go through that calibration procedure, I'm not going to be at that 0.05 I expect. Simply replace that tip at that time.